Good. So, first of all, we would like to start with a very quick introduction round, each of you participants. So keep it very short, only name, company, and we would also like to know what triggered you to join this meeting. And then we will explain a little bit on the project concept. For that, we will have our one of our experts, Katrina's here in this meeting. Unfortunately, our intended project lead, Paolo, is ill today, so he cannot join us. But Katrina's is a more than capable replacement. Then we will finalize and wrap up with a summary of the next steps in this TKI call. And of course, then there's also room for questions and comments, after which we will close the meeting. So let's see. To start with the introduction round then, I will just follow the list of names here on my screen. So whenever you hear your name, please provide a short intro. Daniel, let's start with you.
Hi guys, I'm Daniel Dikowski. I'm the CTO of Redefine Meat, and I'm happy to be here. The research proposal is very relevant to the work that we are doing in Redefine Meat, trying to mimic all the characteristics of animal meat in the plant-based version. And one of them is, of course, recreating the Maillard reaction and the cooking behavior and the aroma that's being created in cooking behavior. So we are very keen to hear more about the proposal and other parties interested in being a part of it. Thank you.
Okay, excellent. Thanks a lot. Glad to hear you were very interested. Dario.
Hi, so I am Dario Battacchi. I am Innovation Project Manager at Unigra, which is an ingredient company in Italy. And among the many product categories we work with, there is also chocolate compounds, and in general ingredients for the confectionery and bakery industry. And we are quite involved with finding alternatives, for example, to cocoa and so on. So we are more than interested in this type of project.
Perfect. Thanks a lot. Also very interesting. Then let's see. I hope I pronounce it right. Jeliana.
Hi. So you can call me Gilly. I work at Redefine Meat together with Daniel. I'm a senior researcher, and obviously the things that Daniel mentioned are also my interest.
Okay, perfect. Thanks a lot. Jessica.
Yeah, thank you. We're Jessica and Anna sitting together, and we're from the company called Northern Wonder. What we're doing is we're developing a coffee-free coffee, and in this coffee-free coffee, we're trying to mimic Maillard reaction as one of the most important reactions in order to generate the flavor. So that's why we're interested in this project.
Perfect, thanks a lot. Stijn.
Yes, good afternoon. I'm Stijn Jumelet. I'm a program specialist in the R&D Technology Solutions team of Jacobs Douwe Egberts. And well, as the world's biggest pure play coffee company, we are obviously very much interested in flavor formation pathways in coffee, but also in coffee alternatives.
Excellent. Thanks a lot. We're covering a lot of nice product segments already, I see. Carola.
Hi everyone, Carola Fischer, product developer from Rama. Of course, we do a lot with flavors, and Dave saw this project and asked me to join because he's very interested in this.
Excellent, and glad to see you made it back home in one piece. We had a nice coffee, let's say breakfast session yesterday morning at the campus. Next one, Margarita.
Yeah, hi, I'm a food scientist from Nova Meat. So we also work with plant-based alternatives, and we have a range of products like chicken and beef, pork, etc. And we are also primarily curious about how the flavors and aromas can develop upon cooking, and how can we mimic it as close as possible to the real meat.
Perfect. Thank you. Paul.
Yes, good afternoon. My name is Paul Klaassen. I'm a principal scientist at DSM Firmenich, located in Delft. I'm involved in several food-related projects where flavors also play an important role. So hence our interest in this project.
Okay, thank you very much. And then finally, last but not least, Winston.
Good afternoon, everyone. My name is Winston Sam. I come from Angel East. Angel East is East Extra, the producer. We would like to participate in this program is because we want to develop our how to say it's flavors, but we use the East Extra as a base. Thank you.
Okay, excellent. Well, thanks a lot for all of your introductions. Then a quick introduction on the lead team.
Dennis, shall I introduce
Yes.
myself as well?
Oh, sorry, I missed one. Sorry.
Just saying.
Apologies.
No
Robert, go
worries.
ahead.
Yeah, okay, I'm Robert. I'm also from DSM Firmenich. I got invited via our colleagues from DSM Firmenich in Delft. I'm based in Geneva, and I'm in charge of the food and flavor reaction lab, developing for the company, so the taste part of the company, all the reaction keys that we need to flavor, now be it plant-based meat or soups and sauces or beverages in all its different formats.
Perfect. And also a perfect link to this project. So thanks a lot, Robert. And again, apologies, I missed you on my screen.
No worries.
All right, so, well, then briefly continuing with the introduction of our own lead team. So Paulo, as I mentioned, is ill, unfortunately, so he cannot join us today. I myself am a business development manager for Wageningen Food and Bio-Based Research, so attached to this project not as much for the content, but more for, let's say, the practical facilitating part. Then Vincenzo, a short intro about yourself, please.
Yeah, I'm a professor of food quality and design. I'm an expert of Maillard reaction, and we are running several projects around this concept of generating flavor by Maillard reaction in a controlled way, especially in alternative of analogs of meat and coffee and cocoa. So that's a bit where the idea came from. So I'm very glad that there is this interest. I'm very sorry, but because it's exam time here at the university, I have to leave you right after this introduction. So, but Catherine will take care of all the questions you might have.
Perfect. Thanks a lot. And of course, education is priority, right?
Yeah.
Katrines.
Yes, my name is Katrines de Jong. As you can see, I'm principal scientist here in flavor. I'm already more than 40 years active in the field of flavor sensory and flavor analytics. And in that way, I contribute also to this project together with Vincenzo and Paolo.
Perfect. Thanks a lot. So then about the project Replicator. The idea behind the whole project came indeed, like Vincenzo said, based on research that they've already been doing for quite some time. We want to look at what you can generate in terms of Maillard precursors instead of adding flavors to food. And that's the whole idea that we set up the project on. So the main presentation that we are going to show you today will dive a little bit deeper in the outline of the project, of the work packages that we envision for this project. We've made, of course, an indication on the budget that we think will be required. We will share some information on the subsidy, because to some of you this might be known, but for some of you as well not. So to just clarify, and finally, we also have the timeline that is set for this subsidized trajectory. Then moving over to the content, and with that I will also move the, let's say, the presentation to Katrines. Can you please take over?
Yes. as every project, we always start, of course, with the objective of a project like this. And our main goal is what is already repeated a few times by Vincenzo, is finding the precursors which are made by a clean label process, as we like most, which will generate and desired brown type flavor upon heating. And that can be, of course, in general in different areas from the meat, what you see here on this picture, but it's also involved, of course, in chocolate or coffee, for example. And what also pop up here a little bit in the EU is that also the smoky profile, for example, is also becoming more restricted. So that could also be a way out of this flavoring issue. The replicator aims at just to create a precursors that after for example, a clean label process like fermentation or another way of delivering these precursors, that we have generating the desired reaction flavors when the product will be heated. So that's the whole objective. Next slide, please. So we're having five different work packages, where for the WP1, 2, and 3 are very active with each other. So learning from the one is directly helping the other one to move on. And the first one is the part from Vincenzo. It is what we much more going in defining the precursors which we need to making this kind of Maillard reactions. A second part is the development a little bit of the strategy. I will go a little bit more detail later, how we can achieve to get these precursors made or having in a project. So at the end, that if we heat it, that we really coming with the flavors itself. There is also another side, and that's more the analysis part of it, because you also like to not test a few possibilities, but we really want to screen a little bit more possibilities. We also have to develop a little bit an high throughput kind of screening, in which this heating and non-heating is part of. And then at the end, we're gonna analyze all kind of ferments and processing samples, in which we're hoping we find this precursor we are looking for, which also deliver again the right flavors at the end after heating. Everything will be at the end coming in a data mining. We call that we create an easy to search database in which you can find back all the results in a way that if you can find the conditions, the microorganism or enzymatics reactions back, which we generated from this project. Next slide, please. So if you're going a little bit more in WP1, defining the precursor compounds, it is the idea that also a PhD student is diving here also a little bit in. A little bit more. So we try to define these Maillard precursors. What do we need to be responsible that we get these heating flavors like roasting, meaty, brothy, bouillon. And we studied a little bit more the chemical roots here within the Maillard reaction, which lead to these desired flavors. As far we don't already know, of course. And the outcome will be used directly to make the choices of the matrices and the screening of the enzymic reactions and fermentations we like to do in the big screening at the end. In the next slide.
Add slightly here that the let's say the further scoping of the specific precursors that we want to look at is also depending on which companies will join in and which end product categories will be of main interest. So we have highlighted a few potential end product categories of interest, but in the end it's up to the partners in the consortium that we will decide which topics will actually be investigated in the project.
Next slide, please. So then the WP1 is the development of the strategies. This is also a little bit referring what you were saying, Dennis, is there we are really going to develop a little bit which type of fermentations, which kind of microorganism we knew, what is exactly the substrates we gonna test, and on both fermentation and enzymatic or also some other process strategy we can think of to develop the desired precursors which will generate this Maillard flavor. This also depends a little bit exactly on which type of projects we are going for, and also the companies who are involved, and setting a little bit the IDs we're gonna generate here. And we do this development, of course, together and within the project. Next slide, please. What we want to say about this development of the strategies looks that we start from scratch. That's not true, because we are already working sometime with all kind of what we call TKI project, bigger projects on WFBR, like cultures and all informed at this moment, in which we do this kind of potential large screenings of fermentations and forming of desired flavor compounds. Again, we are going here to the end flavor, and we don't go into the precursor before. So these are really the compounds which you can say are the flavor compounds generated during these processes. There also start ID from, it would also be nice if we are going one step before, that we could also generate these precursors in which you can develop, you can have the flavor compounds after heating. The result of these former screenings provided direction to develop the right strategy. So that means also we already have some high throughput screenings standing there, but we have to adapt it a little bit to this new question. And also we already did some projects with heating, and we did already some things before, but it's not exactly having the same answer, the same goal, objective we want to have in this project. Then we coming to the analysis part. What I said, we have to adapt a little bit the high throughput analysis we already have to including this heating step. So what is important here that we really talk about high throughput screening. So the procedure that we also want to see is that we want to measure the flavors before and after heating. So that's the ID, and that's not we going to analyze the precursors itself directly, but we want to see what's happening when we having a certain processing defined, what we want to test, that we will see what's happening before and what's happening after the heating step. This whole system has to be incorporated in the existing sample robots, what I already were talking about, but it can also be that we go into glass sample files, which is shooting maybe also a little bit more if we want to heat the sample directly itself. Then an analysis will be carried out with this high throughput screening with high resolution MS systems. That can be in PTR QTOF, but it can also be, for example, an Orbitrap or something coming close to this. This is all in real-time approach based on what we also can do is in having sensors a little bit based on a GC-MS principle, what's called a flavor spec, but we can also do it with a high resolution GC in combination with IMS. And then we don't go directly for the single compounds, but we're looking a little bit to, can we generate a certain profile, what is defined also that we say this is our ideal profile. Do we also generate this profile after heating of these samples? So that's a little bit untargeted approach, where the other one is a little bit more targeted. Yeah, next slide.
I see that Robert is typing. Robert, do you have a question?
I have several questions, but I was
I pay
wondering if I
very
shouldn't
close
better
attention
wait.
to you now.
No, but no, I typed down the questions during the speech of Katrina's. We can maybe go over them in the end, so I don't want to interrupt the flow.
No problem. Yeah.
Perfect. Okay, then we'll continue.
The flavor of the compounds will be what we can say is more the aroma part of the thing, because we want to measure the headspace of the samples, and screening has to be also the screening to be developed has also to be very fast in the way of heating the samples in the well plates or in the glass, I think, applied to the reaction temperature without losing too much of the reaction's key characteristics. Different modes of heating could be that we are heating it in a specially developed well plate. We did that before, but yeah, if you need a lot of these well plates developed, it's a little bit more expensive because it's most of the time it's yeah, it's made of steel. We can also insert a hot needle, for example, in a well of a plate directly to heating up the sample very quickly in that way, and then directly seal the well plates. All we're doing is just in the analytical instrument, and then we need, of course, these glass files instead of that. So there are three possibilities, but what I said, it's a work program, so we have some experience with it, but we have to dive in a little bit more in to adapt these methods for this project. Next slide, please. And then at the end, we're gonna screen the ferments and the processing samples we thought of that would be nice, and we think that there will be positive outcomes out of this. So that will be done in a sort of design of experiments we have to set up for the screening experiments. And we also we are also going what we call more the KIVO compounds, or the key aroma compounds before and after heating, which is the approach which we is more target. And we can also have a look that we going a little bit to the untargeted part of it. And if you're really going with this high resolution mass spectrometry without any GC or something, so we have the direct MS approach, then it could be, of course, that some compounds will have the same mass. So then we have to go also a little bit to a spinning arrow GCMS approach, for example, to identify a little bit the peaks if it's if they have exactly the same mass. So that will be some validation repetitions at the end of the screening. The experiments will be sensory evaluating by sniffing in the headspace, because that's also what we can do. It's not only that we measure these kinds of compounds, but we also can take one of the plates and we just take a funnel, for example, with a little needle, and we can smell a little bit above the headspace of these wells we are generating, for example, especially, of course, after heating. So that's also a little control we can do next to the analytics with the machines. Yes, next slide, please. As we said, the screening will be done of the fermentations and somatic and some chemical process samples, which we analyze using these methods we incorporated. And of course, and what we also have already made is a sort of custom software to process all this data which is generated by these machines. It was developed in partnership with a digital flavor from Porto, and it converts instrument data, and it also helps us to identify the peaks and into Excel tables, which make it easier to perform further multivariate statistics. Yeah, and at the end we can also do a semi-quantification is available for a set of compounds which are already defined. So that's also possible that we also include a little bit maybe things like odor thresholds or odor value that we know a little bit how far we are above the thresholds of these compounds. So not only in concentration but also a little bit more background. Again, this leads again for, of course, the flavors which are generated after heating. Next slide, please. Yeah, the next step is that all the data which we making and all the identifications we do, etc., will come in a database, and we also have to make a nice desktop interface around it, that it is made user friendly, that you can have your questions asked, and that the right information will pop up. So that this also will be a part of this project. I think this is everything, Dennis. Yeah. So
on the content, it is indeed.
Yeah. So if you have questions, please.
Indeed, to ask any content-driven questions at this moment. Robert presses enter. Let's see. Can you see the chat, Katrines?
Oh, sorry, no. I have to. Yeah, the first one to enjoy, Vincenzo. Yeah,
It's not
Robert. Yeah, so I have to take the questions now. Yeah, the fermentation will the fermentation be designed to deliver a bespoke precursor or a mixed pool of precursors? Can you a little bit explain what the question exactly is? So you.
Yeah. I mean, you mentioned Maillard reaction as a very general terminology, and we know Maillard reaction can go off in different directions. So, and that all the precursors deliver the same resulting flavor profile. So that was my question. Do you work on when you design your fermentations, do you want to make a rich mixture, a pool of different type of precursors that then can deliver like a nice mix that goes into, let's say, either the roast, the meaty, or something the dark roast that you need more for coffee, because it's not the same precursor does all.
No, so that's also, in my opinion, a little bit how I see it at this moment is that in WP1 and also with the knowledge here available and also maybe with the partners, that we make choices in this field. And if we want to make, for example, something a little bit going into the meat flavor, that we also already deliver the right, how do you say, substrate with having the right amino acids, etc., that become at the end to the flavor compounds which we are targeting for. And that we can do, and that's a little bit of design we have to make. We can also say, okay, we deliver a special, that's done also a little bit in WP1, that you're going for a set of amino acids, for example, and see which kind of flavor are formed under these conditions. But I think for the screening, it would be, of course, attractive to go a little bit more wider, that you go a little bit more in a mixed pool. Yeah.
Okay.
And again, then we see at the end if we deliver a little bit, also maybe a mix of some compounds, or we all only see maybe a few of these compounds in a higher concentration, and we're missing something. That could also mean at the end that you are using this approach, but you also still have to add some compounds to make your profile round at the end. Yeah.
So is it more that you are targeting intermediates of the Maillard reaction as precursors like aldehydes and consecutively other halfway breakdown products from the Maillard reaction?
Yeah, and that's a little bit, I think, the choice I cannot present now. So if you're going for coffee, for example, then we already know a little bit which type of compounds we are going for to create this type of roasting part of it. But if you go to meat, you are interested again in a little bit other compounds, and as you already said, so this depends a little bit which target compound you are looking for, but also looking at the other side, also the negative part of the things you don't want to have. So that's also part of this project, to make these decisions a little bit, what will be your target. Yeah.
Yeah, so it means you're not looking like for, I mean, the most obvious would be the sugars, of course, and amino. This is not part of the scope, right? Because they are precursors, but we don't need to make them clean label. They are clean label.
Yeah, of course, yes. But I want to see it a little bit broader to look a little bit to some more areas in which we don't know exactly from, and that's also the choice of your substrate maybe. And if we can do a lot of fermentations of a lot of enzymatic reactions, and we can also do that in high throughput screening via the analysis, that's also a little bit exploring a little bit a new area. And that's what we also did with the other projects I was talking about, that just exploring a little bit, what's formed, what's happening, and what's that, etc. And then you get steering in which directions you can go. Is that giving a little bit enough? Yeah. And again, because I cannot be very more specific in that way at this moment, because it depends a little bit on what will be your target, in which direction you want to go. Yeah.
Okay. My second question was to the regulatory environment. I mean, specifically in Europe, precursors have to be labeled as precursors. You cannot hide them when you have a clear intent to form precursors. Or did you already think about how you can get around that pitfall?
No, not exactly. No, that's also something we have to take in setting up the official, how do you say, project in which we say, okay, we have to take care of this this kind of thing, because you can generate something beautiful, but if you cannot use it further, then it will be a problem. Do you have something about that, Dennis? I see you.
Well, I mean, if you ferment a specific substrate, then you have a fermented substrate as a natural ingredient on your ingredient list. But I mean, then the challenge is that you will not have only one precursor in your ferment, of course. So I think the challenge there is, how do you, well, come to a mixture of ingredients that you could either ferment or treat in any other way, to have precursors formed, but still be able to label it as a food ingredient and not indeed as a flavor compound or a precursor or anything from that matter, because I think that the whole clean label aspect is extremely important in this case.
Yeah, exactly. I mean, that is my concern when you say you're forming by intent via fermentation precursors.
Yeah.
So, and that's my question. I mean, somehow it would be a pity then if you do have that, and you couldn't just simply label it as fermentation.
Exactly.
Or as flavoring preparation. But as you do as your intention is to form precursors, actually by the spirit of the law, you should declare it as under precursor. I mean, maybe it's something to take into the consideration.
No, definitely.
Yeah.
And then
but
my
this
last
is not
one,
completely thought out yet.
Yeah, I mean, it's just that you don't bite the whole clean label aspect, that it comes around and bites you with all good intent. But
yeah, it is clean.
Sensory, I mean, you mentioned smelling at the well plates, but you put a huge amount of focus on high throughput screening and analytical techniques.
Yeah.
What is your ratio, let's say, between, on the one side, FTEs on fermentation, and you have the throughput, high throughput, and sensory is almost like an afterthought?
That's correct, because I think that's what I also introduced a little bit, this GC IMS approaches, in which we are looking a little bit more on target, that we have some targeted flavor aspect as sensory we want to have, and that you see if you can find this same type of profile back with this kind of approaches, and therefore we can maybe minimize a little bit the sensory part. Is that if we're really finding something in the area we are attending to, that we then go back a little bit more in the sensory part of the whole thing, because if you're doing all the screening and you do all the sensory above, that will be a very, very big project, I think. But if we find something in our opinion that we think this is of big interest, because this is the way we want to go, that I think it is important, and that's the reason why I mentioned that we also take in account to validate this kind of things on a type of sensory way. And because you're talking about aroma, just my first idea is just to do this by sniffing. Yeah. But yeah, still there is, if you're really having something at the end, I can also imagine that maybe it's more also for the companies itself of bigger interest to test it themselves to see how it will go to the application than it is a part of this project. But again, I like to use this sensory approach. What I said, we can do some sniffing, for example, to see really, because maybe you see a beautiful meaty compound, but if you sniff, you also sniff more off flavors than you sniff this beautiful meaty compound. Yeah, that you're still not there where you like to be. Yeah.
Thank you.
And the last question. Oh, we already.
That was already the last question.
Yeah,
I think, indeed.
It goes. Yeah, the screening is the biggest part, I think, with the fermentations. Then next to it, we gonna validate things. We also go back not only from the machine. I think sometimes you also go back just to GC to be really. Sometimes it's hard on only masters to say which compound we have to deal with. So we have to also to validate that one if it's really this compounds we are looking for. Yeah.
Yeah, and in the end, of course, it will also be depending on how fast we will be able to develop a good screening method, specifically with the heating step, because this is something new that we need to develop for high throughput screening. So yeah, we can anticipate, of course, a little bit what the budget would be that we would need. But yeah, that might be positive or negative. So that's something that we will have to see and steer along the way, I think, as well. And I see a hand from Daniel. Daniel.
Yes. So I'm not sure if I missed this point, or maybe you mentioned it, or maybe you didn't. So what about the characterization of the precursors? Is there any intention of doing molecular characterization of what's inside the fermentation pool, or we only mark it as a certain fermentation conditions that we can probably recreate later on, but without molecular identification?
Yeah, that's in my opinion, and now I miss Vincenzo a little bit because I think that is also part a little bit of the PhD.
It's work package one, yeah.
Yeah, it's work package one. So on one side, we define there a little bit in which direction we're gonna go with WP2. We're gonna screen at the end. We have the outcomes, and then we can go back, in my opinion, also to identify a little bit what we generated there in terms of precursor. Yeah.
Oh, I see. That's actually very smart. So you do not just screen, you do not just identify all of them, but you identify only the most important and interesting ones, right?
Exactly.
That's the idea. Yeah, indeed.
Yeah, beautiful.
Jessica?
Yeah, thanks. One of the questions we were wondering about, I think we know from Maillard reaction that not only volatiles, but also quite a lot of non-volatiles are formed. Katrien, as you mentioned something about headspace analysis. Is it that only then that the volatiles from the Maillard reaction are measured, or is it also possible to measure the non-volatiles?
In principle, in the screening, what we are doing here, we don't look to the non-volatiles.
Okay, clear. Thanks.
Yeah.
Okay. Let's see. I don't see any further raised hands nor questions in the chat. So, okay. Let me then continue with, let's say, the practical part of TKI. For most of you, this will be quite well known, but for some of you not. So just a brief explanation. TKI is a cross-value chain collaboration open to Dutch and also international partners. All the participants in the project will provide one representative in a steering committee, and this steering committee will be sort of will be the providing the guidance during the project. So you're responsible as a committee member for high-level IP oversight, development, dissemination decisions. So basically, all the important decisions that we have to make during the project. Because of course, it already was discussed quite a few times in this call. Of course, we have a project plan at the start of the project, but it's a project of several years, and it will most likely require some tweaking along the way based on the first results that we will gather. And this is also where the steering committee steps in and where you as a partner have a say in which direction it will further develop. Then a little bit about ownership of IP. Ground rule, ownership follows inventorship. So if you contribute as a partner to the formation of IP, You will be also mentioned on the invention form and as also when filing the IP, of course. And then you're also entitled to at least a part of the revenue that will come out of the IP. And next to that, all partners in the project will have a non-exclusive, non-sublicensable right to a license on any IP that is formed within the consortium and then within your field of use. And that's basically your area of business operations that you work in. Obviously, also because we are a partly subsidized project, non-protectable foreground needs to be published, but how and when and where is all to be discussed and decided within the steering committee. Then, of course, we created a budget that we estimate will be required. You can see the details here. We have a PhD, which will cost around €500,000. And then we made some estimations on materials, project support hours, and an in-kind contribution by companies. Total budget will be around €3 million. With a duration of 4 years and an estimated 5 partners that we will require. That amounts to an in-cash contribution of around 50K per company per year. And an in-kind contribution of 25K per company per year. And that is also because we estimate that the bulk of the work really needs to be done at the university. Hence, the in-kind contribution is lower than the in-cash contribution. Details all to be further decided. Also, how we divide in-cash and in-kind across the partners, which will be really depending on the type of partners that we get on board, and also on the amount of partners, the different end product categories that you're interested in, for example. So this is really just the first estimate based on the work packages, and of course there will be boundaries, but that is all to be discussed more in detail later with interested parties. So we also thought about potential consortium partners, and I'm glad to see that we actually have quite a few different of these partners already here on board. I haven't seen any cheese, let's say dairy interested partners, but perhaps within some of the flavor houses. Anyway, if you are interested in joining and if you have any specific industrial partners that you would like to also join, feel free to reach out to them or ask us to reach out to them, and then we can see if we can get them to join. Then a little bit about the timelines. So we are approximately halfway through the whole annual trajectory, which starts typically at April 1st when TKI opens the call. We start with ideation, basically, and we are now in the phase of finding out which of our ideas actually have sufficient industrial interest to, well, basically to justify the writing of a full proposal, which we will have to do mostly in the summertime. So in July, we will make a, let's say, a further internal selection on which ideas we are going to actually write a full proposal, because I think we have 35 or 36 ideas at the moment for which we are testing basically the interest of the industry. And without industrial partners, there will be no subsidy. So basically that will be the main selection criterion. So in July, we expect to lose approximately half of the project ideas, because that is basically the amount of work that we can handle in the summertime. And then we will write a full proposal, which will be submitted in September. By November, we hear then which will be granted, and then we have until April 1st next year to do the contracting, after which we can kick off with the real work. Typically around 50 to 60% of the proposals that we submit is actually granted, so that's quite high for a subsidy. That is also why this is a really important subsidy for us as we're, because of the high success rate. So that's it. from both the contextual part as well as, let's say, the practical, financial, and timeline part. Let's say the last part for me to tell you is that we will provide you with a follow-up via email in which we will send you the link to the recording of this session. So if you feel, well, if you have some time left at some point, you can still review the session, and we will also use it for other parties who could not join today, unfortunately. We will also send you this slide deck, so you can use that for a review as well. And we will send you what we call an inventory form, in which we will have some basic questions for partners that would really like to join in. And then we would like to learn from you what type of, for example, end product category are you interested in, any specific other remarks or comments that you have. Also, we would like to ask you to think already a little bit about your potential in-kind contribution. For example, if you have specific equipment available or raw materials or end products or whatever, everything that we can use in this project, of course, is most welcome. And then, yeah, we would like to learn from you within the next 2 weeks. If there is an interest in further participating, it's definitely not legally binding in any way, but we would really like to consider or to ask you only reply if you are seriously interested, because we will use your interest to filter out the projects with which we will continue to work. And it's, well, to put it very bluntly, really annoying if we are working on a project which will in the end not have sufficient partners because partners are dropping out. So please only apply if you're really interested in helping us to bring this further to a nice full proposal. Besides that, we typically operate on a sort of first come, first serve basis, because this project, well, it is still pre-competitive, but there are definitely also some competitive aspects, we think. So it might be difficult for, let's say, true competitors to cooperate in the project. We can always try, of course, but whenever we're in doubt, then let's say the companies who are already on board have more or less a veto to call if a strict competitor also wants to join in. We are looking for a consortium in which all of the partners are really eager to work together. So otherwise it will not work. Definitely not for 4 years. I think that's it. Yeah, no further things come to my mind. Any further questions after this part of the presentation? I do not see raised hands or questions in the chat. Good. Okay. All right. So thanks a lot for your interest. I think there were some really good questions, critical questions as well. We will send you the follow-up as soon as possible. If you have any other questions that might pop up, feel free to reach out. And we hope that we can welcome a lot of you, perhaps even all of you, on board to make it a really nice project, because the topic is extremely interesting and also very relevant, we think. So thanks again, all of you, for your attention, and we'll be in touch very soon.
Thank you very much.
Thank you. Bye.
Take care.
Thank you.
Bye-bye.
Bye-bye.
Thank you for your time.
Bye-bye.
Bye-bye.